You open the app, pull to refresh, and a list of posts from the people you follow appears in under 200 milliseconds. Simple. It's a query. Give me recent posts from everyone I follow, newest first. And that query, run naively, is one of the most expensive things you can ask a database to do at scale, because the average user is easy and the tail is deadly. A celebrity with 100 million followers posts once, and that single write has to reach 100 million feeds. Design a news feed is the interview that separates people who memorized user cache from people who understand that a feed breaks at the tails, not the averages. The spine of the whole answer. This is a fan-out trade-off. Do you do the work when someone writes a post or when someone reads their feed? Get that one decision right, and everything follows. Functional requirements first, and scope them tightly. Post, follow, and unfollow. View a home feed of posts from the people you follow, reverse chronological or ranked. And pagination, the infinite scroll. Explicitly park what's out of scope. The social graph service, notifications, direct messages, search, so you don't sprawl. You can mention them as neighbors and move on. Now the clarifying questions that signal seniority, ranked or chronological, because ranking changes everything downstream. How fresh must it be? Is a few seconds of staleness okay? Almost always yes, and that is your single biggest lever. A feed that's 5 seconds stale is indistinguishable from a fresh one to a human, and that tolerance is what lets you cache and pre-compute at all. Read-heavy or write-heavy. Feeds are massively read-heavy, and we'll put a number on that in a moment. Non-functional requirements next, and these are what you'll actually design against. The feed read sits in the hot path of every single app open, so read latency is the SLO that matters, P99 under about 200 milliseconds. Availability. You choose high availability over strict consistency. A slightly stale feed is fine. A feed that won't load loses the user. That's a CAP theorem stance, and you should name it as one. Under a network partition, you serve possibly stale data rather than an error. Say that trade-off out loud, because it quietly justifies half the decisions that follow. Do the math out loud, because the numbers pick the architecture for you. Say 300 million daily users, each opening the app about 10 times a day. That's 3 billion feed reads a day, roughly 35,000 reads per second on average, call it 100,000 per second at peak. Writes, people post far less, maybe 5 million posts a day, about 60 writes per second. So the read-to-write ratio is roughly 500 to 1. That ratio is the single most important number in the whole design. It says, optimize the read path, even if you have to pay a lot more on writes. Storage, posts are small, a few hundred bytes plus a media pointer. So 5 million a day at 300 bytes is about 1.5 gigabytes a day of post metadata. The media itself goes to a blob store and a CDN. But now, size the thing everyone forgets. The pre-computed feeds themselves. 300 million users, each holding a capped list of, say, 800 post IDs at roughly 16 bytes each. That's about 4 kilobytes per user, so a bit over a terabyte of feed data living in memory across a Redis cluster. That number is why the feed store is sharded and why you cap the list length. And here's the framing that decides everything. The feed is derived data. You can always recompute it from the posts, so it's a cache, not a source of truth. 3 numbers: the read-write ratio, the media footprint, and the in-memory feed size. And each one makes a design decision for you before you've drawn a single box. The first model is fan-out on read, also called pull. Do nothing at right time. When a user opens the app, you query their feed live, get everyone they follow, fetch their recent posts, merge sort them by time, return the top N. The pros are real. Writes are trivially cheap. You just store the post once. There's no wasted work for inactive users, and most users on any platform are inactive on any given day. And the feed is always perfectly fresh, because you're reading the source of truth directly. But here's the fatal flaw at scale. Every read is expensive. If you follow 500 people, that is a 500-way scatter-gather plus a merge on every single app open. And you're doing that 100,000 times a second. Trace where that cost lands. It's 500 index lookups against a posts table that's being read by the entire planet at once. And the P99 of your feed is now the P99 of the slowest of those 500 queries. The tail of a tail. Your read latency explodes, and the database melts. Pull is the right choice for write-heavy, read-light workloads, or for users who follow enormous numbers of accounts where pre-computing would waste effort. But as the default for a read-heavy feed, it fails the 500-to-1 ratio outright. So we do the opposite. So flip it. Fan out on write, push. When you post, you pre-compute. You push that post's ID into a per-user feed list for every one of your followers, right then, at right time. Think of a Redis list or sorted set per user, keyed by user ID, holding just post IDs. Now a read is trivial. You fetch your own pre-computed feed list, already assembled and waiting. That's what makes reads O of 1 and blazing fast, and it's exactly why push is the default for a 500-to-1 read-heavy world. You do the expensive assembly once, at right time, and then serve it cheaply to every one of that user's 10 app opens a day. The costs simply moved to right time. One post now becomes N writes, one per follower. And critically, that fan out never happens inside the post request itself. The user's post returns the instant it's durably stored, and a background worker, fed by a queue, does the fan out asynchronously. For a normal user with a few hundred followers, that's completely fine. A few hundred tiny list insertions that finish in well under a second, and nobody's waiting on them. But notice what you've just built. You've planted a bomb. What happens when N is not a few hundred, but 100 million? Here is where the interview is won or lost. A celebrity with 100 million followers posts. Fan out on write says, perform 100 million feed list insertions. Now, that is the write storm. A single write saturates your fan-out workers and your storage queues. And here's the subtle, senior insight most candidates miss. The visible symptom isn't the celebrity being slow. It's everyone else's read P99 blowing past 200 milliseconds because the whole system is choked copying one post 100 million times. One user's write just degraded 1 million unrelated users' reads. A feed breaks at the tails, not the averages. The fix every large platform converged on is the hybrid, push plus pull. For normal users, you fan out on write, fast reads, cheap writes. For celebrities above a follower threshold, you do not fan out. Their posts are fetched on read, pulled, and merged into the feed at query time. So a user's feed equals their pre-computed push feed for normal follows, plus a live pull of the handful of celebrities they follow, merged together at read time. You pay a tiny read cost only for the rare hot accounts, and you completely kill the write storm. Now defend the threshold, because a good interviewer will push here. Where do you draw the celebrity line? 100,000 followers. 1 million. It's not a magic constant. It's a tuning knob that trades write amplification against read cost and you set it from the actual follower distribution. And notice the merge isn't free. Pulling a celebrity's recent posts on every read means those posts must be cached hot, or you've just moved the bottleneck from the write path to the read path. The truly senior move is to say the split can be dynamic. A normally normal account that suddenly goes viral gets promoted to pull mid-flight, so you never eat the right storm, even for a brand new celebrity. Naming all of that, hybrid, attuned threshold on follow account, pull and cache for celebrities, and dynamic promotion, is the staff-level answer. So what actually holds these pre-computed feeds? A fast in-memory store, Redis, holding a per-user list of post IDs, not the full posts, just the IDs, to keep each list tiny. You hydrate the actual content from a separate post store on read. Be specific about the data structure, because the interviewer will ask, a Redis sorted set, scored by timestamp or by rank. So inserts land in order, and you can slice the top N in log time, and you cap each feed at, say, the most recent 800 IDs. Trim on every insert, because nobody scrolls past that. And unbounded lists are a slow memory leak that will eventually take you down. Now sharding. With over a terabyte of feed data, this cluster is sharded by user ID, so a given user's whole feed lives on one shard, and a read is a single node hit, no scatter-gather. The posts themselves live in a separate durable store, sharded SQL, or a wide column store like Cassandra keyed by post ID, fronted by its own cache, because a viral post gets hydrated into millions of feeds, and you do not want a million database reads for one post. Here's the key insight to say out loud. The feed list is derived, disposable data. If Redis loses a feed, a node dies, a cache flushes, you rebuild it from the post store by rerunning the fan-out for that user. So it's a cache you can always regenerate, which means you tune it purely for speed, not durability. You can even run it with weaker persistence than you'd ever accept for the source of truth. That single reframing, the feed is a cache, the posts are the truth, is what keeps the whole design honest. And it's the sentence that tells the interviewer you actually understand the system instead of memorizing a diagram. Let's make it concrete. Trace a post through the system, then break it at every stage. You post. First, we write to the durable post store, the source of truth. Then a fan-out service reads your follower list. For normal followers, it pushes the post ID into each of their Redis feeds. If you're a celebrity, it skips fan-out. You'll be pulled later. Break it. The fan-out worker crashes mid-push, so some followers miss the post. Fix. Make fan-out idempotent and retriable through a queue like Kafka, and let reads fall back to a pull merge so the system self-heals. Now, a follower opens the app. We read their Redis feed list, fast, merge in the live pulled celebrity posts, hydrate the post IDs into real content from cache, rank them, paginate, and return. Break it. The Redis feed is cold or missing. Fix. Rebuild it from the post store on the fly. That's degraded latency, not an error. Every stage degrades gracefully. Nothing ever hard fails. That walkthrough is what defending the design looks like. Chronological is easy. A ranked feed, what Twitter, Facebook, and Instagram actually ship, changes the game. Instead of newest first, you score each candidate post with a model. Engagement probability, recency, your affinity to the author, content type, and you sort by that score. Architecturally, this means the feed list stops being the final answer and becomes a candidate set, and a separate ranking service scores those candidates, either at read time or pre-scored. The trade-off. Ranking adds read path latency and real complexity, and it needs feature data, your past engagement, the author's signals, freshness. And here's the staff nuance. You separate candidate generation, which is what fanout gives you, the pool of eligible posts, from ranking, the model that orders that pool. Two distinct stages, and they scale independently. That separation is what lets you evolve the ranking model constantly, ship a new model weekly, run A/B experiments without ever touching the fan-out plumbing underneath. But ranking reintroduces a latency problem we thought we'd solved. Scoring a few hundred candidates through a model on the hot read path can cost more than the fan-out ever did. So the real systems do two things. They keep the candidates set-bounded, a few hundred posts, not thousands, and they pre-compute or cache the expensive features, so scoring is a cheap dot product, not a database trip. Say that out loud. Fan-out solved read cost, and then ranking threatened to bring it right back, so you budget the ranking latency explicitly. That awareness that every new layer has its own tail is what staff level actually sounds like. Let's hit the follow-ups that separate senior from staff. Staleness versus cost. The feed is eventually consistent. A few seconds late is invisible, and it buys you enormous scale. So name it as a feature, not a bug. The thundering herd. A viral post everyone loads at the same instant. Cache it hard and dedupe the hydration. New follows and backfill. When you follow someone, do you backfill their recent posts into your feed? The pull merge path handles that cheaply. Deletes and edits. A deleted post is already fanned out to millions of feeds. You don't purge it from all of them. You filter at red time with a tombstone check on hydration. Pagination. Use a cursor. The last seen post ID or score never offset, so infinite scroll stays stable as new posts arrive at the top. And observability. The one alert that truly matters is red P99, broken down by feed size. Because the tail, the users who follow many accounts or follow celebrities, is exactly where it degrades first. The red flags, the traps that sink candidates. 1. Fan-out on write for everyone, which detonates the celebrity write storm. Fix it with the hybrid and pull for celebrities. 2. Pure fan-out on read as your default, so your read P99 melts under the 500:1 ratio. Fix it with push for normal users. 3. Storing full posts in every feed instead of IDs, which blows up memory. Store IDs and hydrate-on-read. 4. Treating the feed as a source of truth. It's derived and disposable, a rebuildable cache. 5. Unbounded feed lists, cap them to the recent N. 6. Offset pagination, use cursors. 7. Purging deleted posts from every feed, filter at read with a tombstone. 8. Chasing strong consistency when embracing staleness is your biggest scale lever. 9. Synchronous fan-out inside the post request. Make it async through a queue, idempotent and retriable. And 10. The meta flag, optimizing for averages. Always design for the tail and the P99 and the celebrity case. Let's zoom out. The feed is a fan-out trade-off. Push, fan-out on write for the read-heavy default. Pull, fan-out on read for celebrities. So the hybrid is the answer, and it exists specifically to kill the write storm. Store post IDs in a disposable Redis feed cache and hydrate the content on read. Separate candidate generation from ranking so the model can evolve on its own. Embrace staleness, paginate with cursors, and above all, design for the tail. Because a feed breaks at the tails, not the averages. Master that, and you can design any feed and defend every failure mode. But knowing it and performing it under pressure are two different skills. Practice this exact interview with an AI interviewer that pushes back like I did, free at crackit.io. Design the system, then go defend it. See you in the next one.